Okay, so in the last video, we talked about what an arithmetic sequence is. And this one, we're going to be talking about graphing them. And so what we learned is that an arithmetic sequence is a consistent change or rate of change within a series of numbers. Now, graphing them requires us to create a table of values and to create a formula in some situations. And so what we're going to start with is this question right here. So it says, a car salesman receives a basic salary of $300 a week plus an additional $200 for each car that he sells. If over a 10-week period, he sold 0 cars the first week, 2 cars the next week, and then 1 more car per week after that, construct a graph that shows his weekly income. So I am going to start by creating a table of values here. So I'm going to title this side, which would typically be my X, number of cars sold. Okay, and then this one is weekly income. So the first week, he sells 0 cars. Okay, so this one says he sold 0, zoom out a little bit, cars the first week, 2 cars the next week. So for the first week, 0 cars, which means our weekly income is just the basic salary. If he sells 1 car, it's $300 a week plus the $200. So it is $500 that week. And for the third week, or the second week here, we're going to have plus another $200 because in this week he is selling 2 cars. So that is going to bring us to $700. Now I could keep going and I'll fill this in just for us for the sake of understanding here. So 3 cars is $900. That's the base salary plus 3 times 200. And then 4 cars is $1,100. And 5 cars is $1,300. 6 cars is $1,500 or $1,500, and so on. You could keep going and going and going up until 10 weeks. So that specific question says if over a 10-week period. So you should consider going all the way down to 10. But just for the sake of this video, I am going to write these out really, really, really fast for you. So 17, 19, 21, and 23. Now, going to graph this, you want to make sure that you take your time and you pick proper axes that are going to work for your graph. So I'm going to readjust these guys here just so that we can graph properly. And so I'm going to do this as my X here, which is number of cars sold. So 1, 2, 3, 4, 5, 6, 7. And then up this side, I'm going to go up by about 200 each dot. So 200, 400, 600, 800, 1,000. And then 1,200. Sorry, I forgot what I was doing. 1,400, 1,600, 18, 2,000, 22, and 24. Okay, so each point that I have graphed or written in my table of values, I can now graph. So 0 cars sold, which would be this one here, gives us $300. So that right there is an important value. That's our starting value, also known as our y-intercept. When 1 car is sold, we go up to 500, so right in here. When 2 cars are sold, we go up to 700, so right in there. When 3 cars are sold, we go to 900. 4 cars are sold, we go to 1,100. 5 cars, 13, and so on. You'll start to see that we get this really nice line once it straightens out. That's obviously a little off because it's not perfect and my drawing is not perfect, but the idea is there. Now, these are technically discrete values, which means that they are not connected. They're not connected by a line because this amount of money here does not actually exist in our formula and we're given what we are given. Now, we also might be given a formula that we were given before. So Tn equals A plus N minus 1 D, where A is 22 and D is 13, and be told to graph it. So if I plug this in and make a little table of values, the N value is going to go here and the Tn will go there. So if N is 1, I'm going to plug 1 into my formula. So I will have Tn equals 22 plus 1 minus 1 times by 13. So 1 minus 1, 0, times by 13 is going to be 0. So 22 plus 0 equals, didn't need to write the second 0 there, 22 plus 0 equals my term number. And my term number then just equals 22, and that can go in my chart there. And you could continue to do this for however many terms you feel is necessary or the question asks you to go for. So if it asks you for the first 5 terms, you're going to find the first 5 terms in a table of values, and then you are going to plot them on a graph. In both examples, the graphs do lie on a straight line, and the difference between each dot is our constant. Now in later videos, we'll talk about that being the slope, and we'll figure out how to find slope more consistently, but that is what we need to know for now.